In this video, I look at average gradient and gradient at a point. Okay. Now, the first thing I want to emphasize is that average gradient is the gradient between 2 points, and gradient at a point is at 1 point. Now, don't take that for granted. Wonder about it. Okay. So up until now, we have worked with gradient and using the formula m equals y2 minus y1 over x2 minus x1. Now this is the formula for average gradient. And to calculate the gradient using this formula, we've always needed 2 points. Okay. Now, this formula also gives us the gradient of a straight line. And we know that the gradient of a straight line is constant. It doesn't change along that line. But if we look at a parabola, the gradient of a parabola is not constant. And in fact, it changes for every point on the graph. So if we look at a parabola, I am interested in knowing the gradient of this point. Now, I can use average gradient and find a measurement of the gradient at that point. So I could pick that point and choose one other point on the parabola. I can calculate the average gradient of this parabola by using those 2 points. What I'm actually calculating is the gradient of the straight line that passes through those points. Now, while that might be an average gradient for the parabola, it's not accurate for this point that I'm interested in. So I might choose a point that is slightly closer along the parabola to the point that I'm interested in. And I can work out the average gradient. I have the 2 points. I use the formula. I work out the average gradient, and the gradient might be slightly closer to the gradient at the point that I'm interested in. Okay. If I keep choosing a point that is increasingly closer to that point, I can eventually have my 2 points be on top of each other. Okay. The straight line that I would then have at my point would be the tangent to that point. So that brings us to a very important concept. The gradient at a point on a parabola is equal to the gradient of the tangent to the parabola at that point. Now, this is a very important concept, and we will be using this concept in calculus next year. So make sure you take note of it and understand it. Okay, now we are going to take that concept and look at an example. Now, in this example, we are given the parabola y equals a half x squared plus 6x plus 18, and its tangent y equals 2x plus 11 intersect at the point -4, 3, and on the graph the point is over there, and we see the parabola and the straight line, which is the tangent, and we were given its equation as y equals 2x plus 11. Now if we look at question A, it says give the gradient of the parabola at the point, so just at one point, -4, 3. Now, the important concept said that the gradient of the parabola at a point is the same as the gradient of the tangent to the parabola at that point. Okay. Now, we know the equation of our tangent at that point, and because we know the equation, we know its gradient is 2. Therefore, the gradient of the parabola at the point is 2. M equals 2. Question B says, will the curve, which is the parabola, be steeper at A or B? Okay, now if you want to visually compare them, draw tangents at A and at B. So the tangent at B would sit there, the tangent at A would roughly be there. Now, we can compare the gradient of the tangent to see which point the curve is steeper. And it is clear that at A, the gradient is steeper. So, will the curve be steeper at A or B? At A. Okay, I'm writing very short answers here. Right. Where will the parabola have a gradient of 0? Now, we know that horizontal lines have a gradient of 0. But we also know that a gradient of 0 exists where a graph is neither increasing nor decreasing. So if we look at the parabola, the point at which the graph is neither increasing nor decreasing is the turning point. But the tangent at the turning point is a horizontal line. And that's why the two go together. So where will the parabola have a gradient of 0? At the turning point C. Right, question D says, which of the 4 points has a negative gradient? Now, we know that a decreasing graph has a negative gradient. And if we compare the points, A has a positive gradient, B has a positive gradient, C has no gradient, it's 0. And at D, our tangent is a decreasing graph, so that would have a negative gradient. So which of the 4 points? It is D. And that's it.